The Sun consists of hot plasma and releases many kinds of radiation. The radiations are the source of the heat for the Earth. However, among the radiations of the Sun, ultraviolet, which is usually called UV, is harmful. UV radiation could damage eyes. If your eyes are exposed to strong UV radiation for a short period of time, your eyes may turn red and you will have a foreign body sensation and gritty feeling in eyes. That is keratitis. If the exposure is long-term, that will cause eye cataracts. Exposure to too much UV radiation could result in damage to DNA. Under excessive amounts of UV, skin cancer would be widely spread. Radiation causes deformed morphology for plants, such as changes in plant height and leaf area. Animals also suffer the negative effects of UV radiation. Fortunately, the Earth has an umbrella to protect itself from UV radiation. This umbrella is ozone layer. There are two layers of atmosphere on the Earth, the troposphere and the stratosphere. The ozone layer is at the bottom of the stratosphere. The ozone layer is 20 to 30 kilometers above the Earth. The thickness of the ozone layer, usually several millimeters, depends on latitude and season. The solar intensity and atmosphere circulation patterns affect its thickness. The ozone layer absorbs 91 to 99% of the Sun's UV radiation, like a shelter for the Earth. With the energy of UV light, an ozone molecule would break into an oxygen molecule and an oxygen atom. Then the radiation is no longer harmful. However, the ozone layer is depleting. Ozone layer depletion is caused by chlorofluorocarbons, which are usually called CFCs. Air conditioners, refrigerators, fire extinguishers, spray cans, and so on are major sources of CFCs. The CFCs are stable below the stratosphere. However, when they reach the stratosphere, carbon chloride bond breaks with the energy of UV light. The free chloride radical is made as the reaction shows. The free radical contains a large amount of energy. The chloride radical breaks down the ozone molecule. This whole process creates oxygen, but the free radical remains in the atmosphere and continues to work in this way. Due to the low temperature at the Antarctic, CFCs condense in this area. The depletion is harsher here, and then the Antarctic ozone hole appears.
The discovery of the ozone hole was probably one of the significant environmental discoveries of the 20th century. Nobody had expected such a dramatic change to be seen over Antarctica. What the ozone hole does is it allows more ultraviolet light through to the surface. Now that's a problem for living things at the surface, mostly in fact for us. Several things were key to our discovery. One was the fact that we'd used the Dobson ozone spectrophotometer for the entire period since 1956. That continuity was important because we could be confident that any changes we saw were changes in the atmosphere, not in how we made the measurements.